Hi guys, let's look at the next question. The next question that we do is question number 15. It says ABCD is a cyclic quadrilateral, PQ is tangent, BD is diameter. If angle DCQ is equal to 40 degree, ABD is 60, we need to find DBC, which is this angle, BCP, which is this angle, and ADB, which is this angle. Perfect. So I have an angle between a tangent and a chord. So let's try and identify the angle in alternate segment. So if QC is the tangent and DC is the chord, then the angle made in the alternate segment would be angle DBC. So this angle would be 40 degree. Let's just write this down. Point number 1, angle DCQ is equal to angle DBC is equal to 40 degree. Angle in alternate segment. Done that, the first part of the question, we figured out angle DBC. Next, angle BCP. Okay, so this angle obviously is 90 degree angle in a semicircle. So point number 2, angle DCB is equal to 90 degree angle in a semicircle. What this means is 90 degree plus 40 degree plus angle BCP is equal to 180 degree. This is angle on a straight line, which means angle BCP is equal to 180 minus 130, which is equal to 50 degree. So we've got the second part of the angle as well. This is 50 degree. Similarly, this is 90 degree, which is 150 degree, which means this is 30 degree. Point number 5, angle BAD is equal to 90 degree. Reason, angle in a semicircle. What this means is 90 degree plus 60 degree plus angle ADB is equal to 180 degree. Therefore, angle ADB is equal to 30 degree. Done. We figured out all three angles. Let's look at the next question. The next question that we are doing is question number 16. It says the given figure shows a circle with center O and BCD is tangent to it. Show ACD plus BAC. Let's just join O and C. Let's see what this helps us. This angle here would be equal to 90 degree. Yes, why? Angle between a tangent and the radius. I know this angle, this side and this side are equal because of radii are equal. Let this side be, let this angle be x, let this angle be x, let this angle be y. Let's just write that down. Point number 1, join OC. Number 2, OA is equal to OC, radii of same circle. What this means is triangle OAC is isosceles. What this means is angle OAC is equal to angle OCA is equal to x. Point number 5, angle ACD is equal to y. Let angle ACD is equal to y. Number 6, angle OCD is equal to 90 degree. Reason, angle between radius and tangent. So as per the diagram, what we have is angle OCD is equal to 90 degree is equal to x plus y. Now let's look at the left hand side. Left hand side here is angle ACD plus angle BAC. Angle ACD is equal to y. Angle BAC is equal to x, which is equal to 90 degree. This is from 7. Therefore, angle ACD plus angle BAC is equal to 90 degree. Very simple one. Unlikely that you will get such a simple question in any examination. Let's look at question number 18. It says AC is given equal to AE. We need to show that CP is equal to EP. Okay, we need to identify certain triangles which we'll have to prove congruent to be able to prove something equal. So let's look at this first triangle, which is ABE. I will draw this triangle separately so that I am able to identify each side, and I will look at triangle ACD. Perfect. So this is ADC. Angle A is common to both of them. Yes. AC is given equal to AE. Yes. And I will get angle BCD, which is angle ACD here, will be equal to angle BEA, equal to angle here. Why? Because these are angles in the same segment. Let me write this down. Point number 1. In triangle ABE and triangle ACD, what I have is angle BAE is equal to angle BAC. This is common angle. This is angle common to both the circles, both the triangles. Point number 2, AE is equal to AC. This is given. And point number 3, angle BCD, which is equal to angle ACD, is equal to angle BED, which is equal to angle BEA. Reason for this, angle in same segment. So I looked at the segment BD, and these two angles will be equal, which means therefore by angle side angle test, I have triangle ABE congruent to triangle ADC. What this gives me is AB is equal to AD, CP, CT, C. What this helps me is C minus AB is equal to AE minus AD, which means this is since AC is equal to AE and AB is equal to AD. What this gives me is AC minus AB, which is BC, is equal to DE. Now once I've got this, it will help me prove the other two triangles congruent. Now this time I look at BCP, and let me just highlight these two triangles that I'm trying to prove congruent, BCP and triangle DPE. Now this would be easier to prove now that we've got two sides already equal. So what we have equal is BC is equal to DE. This angle and this angle are equal. These are vertically opposite angles. And angle EPD, or rather EDP, and angle CDP are equal. These are angles in the same segment, which means by angle side I should be able to prove them similar. So next, point number 8, in triangle BCP and triangle DEP, what I have is angle BPC is equal to angle DPE, vertically opposite angles. Next, angle EDP would be equal to angle CBP. This is angle in same segment. And then the last part would be BC is equal to DE. This is from 7. What this gives me is therefore triangle BCP is congruent to triangle DEP by angle side test. So if this is done, what I will have is CP is equal to EP. Yes, and I will also have BP is equal to DP. This is CP, CT, C. This is what they wanted us to prove. Done. Very interesting question. Uses the congruency and uses the properties of a circle. Let's look at the next question. The next question that we're doing is question number 20. It says in the given figure, O is the center, tangents at A and B meet at C. If angle ACO is equal to 30 degree, we need to find angle BCO. So this is the angle that we need to find, angle AOB. This big angle here, angle APB, this angle here. Okay, so let's look at triangle. So this angle we already know is 90 degree. This angle we know is 90 degree. APB would be simple to find if we can find AOB. This would be angle at center would be 2 times angle at circumference. So in triangle AOC and triangle BOC, what do we have? Point number 1, OA is equal to OB. This is radii of same circle. Point number 2, AC is equal to BC. This is tangents from a point are equal. Next, point number 3, OC is equal to OC. This is common. Therefore, by SSS test, triangle AOB is congruent to triangle AOC. I'm writing this wrong. This is AOC. I'm looking at AOC as a triangle. AOC is congruent to triangle BOC. What this means is angle ACO is equal to angle BCO is equal to 30 degree. The reason for this is CPCTC. So I've got my angle BCO. This is the first thing that they wanted us to figure out. Let's look at the second part of the question, which is AOB. Now, angle OAC is equal to angle OBC is equal to 90 degree. This is angle between radius and tangent, which means in quadrilateral OACB, 90 degree plus 90 degree plus 60 degree, so say this is 30 plus 30, plus angle AOB would be equal to 180 degree. Reason for this, angle sum property, which means angle AOB would be equal to, this is not 180, this is 360, my mistake. This is sum of quadrilateral, which is equal to 360 degree minus 180 plus 60, that's 240 degree, which means angle AOB is equal to 120 degree. Done. Second part of the question done. That brings me to the last part, which is angle APB would be half of angle AOB is equal to 60 degree. Reason for this, angle at center is equal to 2 times angle at circumference. So this part of the question also done. So all 3 parts of the question done. Let's look at the next one. The next question that we're doing is question number 21. ABC is a triangle with AB is equal to 10 centimeter. Okay, so this is 10. Next, we have, this is question number 21. This is 10. BC is equal to 8. Okay, and AC is equal to 6. Perfect. 3 circles are drawn. Find radii of the circle. So AP, let's say, is X, AQ is X, BP is Y, BR is Y, CR is Z, CQ is Z. I could have taken this as X6 minus X, well, doesn't matter, whichever method you use, it will still work out to be the same. This could be 6 minus X, this would have been 10 minus X. So let's just try. So point number 1, AP is equal to AQ is equal to X. Next, CQ is equal to CR is equal to Z. Number 3, BP is equal to BR is equal to Y. This is the radii of same circle. What is given is x plus y is equal to 10. What is given is y plus z is equal to 8 and x plus z is equal to 6. This is given. Let's add. So add 4, 5 and 6. If I add left hand side, it will give me 2 times x plus y plus z. This is 2x, 2y, 2z is equal to 10 plus 8, 18 plus 6, 24, which means x plus y plus z is equal to 12. Now I need to find the value of x, y and z. So I know x plus y is 10, which means 10 plus z is equal to 12, which means z is equal to 2 centimeter. Next, I know y plus z is 8, which means x plus 8 is equal to 12, which means x is equal to 4 centimeter. Done. Point number 10, I know x plus z is 6, which means 6 plus y is equal to 12, which means y is equal to 6 centimeter. So we need to find the vertices of radii of the C circle. Therefore, radii are 2 centimeter, 4 centimeter and 6 centimeter. Good. Let's look at the next question. The next question that we're doing is question number 23. So question number 23 says semicircle with center O and diameter PQ. PA is equal to AB. Okay, so PA and AB are equal, which means this angle here and this angle here are equal. Why? Angles subtended by the same equal chords are equal. Done. Angle BCQ is 140. We need to find PAB. I have to find this big angle here, AQB. So I have to find this angle here, and we need to prove that these two lines are parallel. Let's just join A and B. Sorry, P and B. Let's see how does this help us. This angle would be 90 degree. Yes, this angle here is 40 degree. Why? Because PBCQ is a cyclic quadrilateral, which means 140. So this is 40. Let's just write this down. In cyclic quadrilateral PBCQ, or before that I have to join PB. What I get is angle BCQ plus angle BPQ is equal to 180 degree, which means angle BPQ is equal to 40 degree. How does this help us? Let's see. Next, point number 4, angle PBQ is equal to 90 degree, angle in a semicircle. Yes, so which means in triangle PBQ, I have 90 degree plus 40 degree plus angle PQB is equal to 180 degree, which means angle PQB is equal to 50 degree. Next, angle PQA is equal to angle BQA is equal to angle PQB upon 2. Reason for this, equal chords subtend equal angles, which means angle PQA is equal to angle AQB is equal to 50 degree upon 2 is equal to 25 degree. So we've got angle AQB. So we've got angle AQB as 25 degree. This is 25 degree. Now OQ and OA are equal. Why? These are radii of the same circle, which means this angle is 25 degree. Why? Because this is an isosceles triangle. So if this is 25, then I have been able to prove PQ and AO are parallel, because if PQ and AO are lines and AQ is the transversal, these are alternate angles, interior alternate angles. Since they are equal, these are parallel. So that part also done. I still need to find these two angles. Okay. Let's look at the cyclic quadrilateral PABQ. Now that we've got this angle. So point number 9, in cyclic quadrilateral PABQ, angle PQB plus angle PAB is equal to 180 degree, which means angle PAB is equal to 180 degree minus 50 degree is equal to 130 degree. So we've got angle PAB as well. Next, since OQ is equal to OA, reason is radii of same circle. What this means is triangle OAQ is isosceles. What this means is angle OAQ is equal to angle OQA is equal to 25 degree. So number 13, since angle OAQ is equal to angle AQB is equal to 25 degree. This is from 12, where we have OAQ, and AQB is from 8. And these are alternate angles. Therefore, PQ is parallel to AO. Hence, rule. So that finishes this video as well as this question for me. Like I said earlier, some questions from this chapter are cancelled because some portion this year has been cancelled. So question 1, question 4, question 10, question 17, question 26, all these are cancelled from this year. Let me mark some homework question for you. Homework question for you for this exercise would be, for this video would be question number, let's say 19 and question number 25. These are two our homework questions. Thank you so much. Take care. Be safe. I'll see you with the next video. Bye bye.